Welcome to the second and last part of lesson 48B. Since lesson 37, we've been using the locus definition and the distance formula to write the equation of a line that is equidistant from two designated points. This line bisects the line and connects the 2 points, and it's perpendicular to the segment. There's another faster way to find the equation of a line that is equidistant, and then we can use it to write the perpendicular line. So if we bisect the line using the midpoint formula, that is the method we're going to use, then we can find the perpendicular of the line of that line by just flipping the slope. So that's what we're going to do. So the midpoint formula is the midpoint of x. You take x1 plus x2, you add your 2 points together that form your line and divide it by 2. And for the y, you do the same thing. You y1 plus y2 divided by 2. And then that gives you the midpoint of that line, xm and ym. Very easy, very straightforward. It's a lot easier than using the distance formula. So let's apply that. We're going to do 48.3. I've already got it written out for us to save us a little bit of time. And as I'm talking it through, you guys can write through the notes. Pause me if I don't give you enough time to write it all out. So 48.3 says to find the equation of the perpendicular bisector. Bisector is our key word here. Of the line segment whose endpoint coordinates are, and it tells us the 2 points, 4, 2, and 8, negative 3. So here I have a little illustration of that line, 4, 2, and 8, negative 3. This is our line. And to find the bisector, we're just going to find the midpoint, right? And that's the midpoint here. But first we need to find the slope of the line. So we made our little right triangle, we counted, and we have 4 to the right and 5 down. So it's a negative 5 over 4 for our slope, which means our perpendicular slope is the reciprocal fraction and the opposite sign. So that's going to be a positive 4 over 5 for our perpendicular slope. So let's find our midpoint using the midpoint formula. So we just take our two x values, 4 and 8, add them together, we get 12 divided by 2. So our x value, our x point is 6. And then our y value is going to be 2 plus negative 3. So it's 2 minus 3 divided by 2. So it's going to be a negative 1 divided by 2, or 1/2. So we would find that point on this line. It's right here. 6 and negative 1/2. If you look, it's exactly where it's supposed to be. So that is 6 and negative 1/2 is our midpoint of this line. Now to get the perpendicular bisector or the perpendicular line, we need to find where it intercepts the y-axis. So we're going to do that just by putting in the perpendicular slope and taking the point that we found and substituting it into what we would normally do to find our plus b. That's all we're doing. So our y is negative 1/2 and our x is 6. We plug that in, when we get our common denominator, we get negative 5 over 10 is equal to 48 over 10 plus b. When we subtract 48 over 10 from both sides, we get negative 53 over 10, which reduces to negative 5.3, which helps us to find the y-intercept for our perpendicular bisector. And that allows us to draw our line from here to here. That also gives us our point, so we can write the equation of the line that is the perpendicular bisector of the line we were given with these 2 points. Easy peasy. You guys know how to do this. You've got a little bit easier formula to get you there. The distance formula takes a few more steps than the midpoint formula. So use the midpoint formula. It's, we like to do succinct. In mathematics, this is more succinct. So let's do 48.4. It's very similar. All right, so here we have 48.4. And it says to write the general form of the perpendicular bisector of the line segment whose endpoints are 4, -3, and -2, -5. So there are a few keywords we have to look at here. So first of all, it says general form. So we have to remind ourselves what the general form is, and that's right down here. The general form is ax plus by plus c. This is your x term, your y term, and this is going to be your plus b, right? Your plus b, or your y-intercept is the c. That's what that represents. So we also need to find the perpendicular bisector. That's the key word here. So we're going to use the midpoint formula to find where it is bisected. And first we have to find the slope and flip it to get the perpendicular part. So let's start with finding the slope. We know that m is the slope. So we take y2 minus y1 over x2 minus x1, -5 minus -3 over -2 minus 4. We get -2 over -6, which gives us a positive 1/3. So that means our perpendicular slope is going to be -3 because it is the reciprocal fraction, 3 over 1, and the opposite sign. So that'd be a negative instead of a positive. So our equation of the line for the perpendicular bisector, or a perpendicular line, is going to be y equals -3x plus b. Now to find the bisector, we have to have the midpoint. So now we do the midpoint using these points here. So plus 2, or -2 plus 4 divided by 2 is 1. That's our x value, and our y value is going to be -3 minus 5, which is -8 divided by 2 would be -4. So our midpoint of this line is 1, -4. So we're going to sub those in to our perpendicular equation of the line, and we are going to get -4 is equal to -3 plus b. We add 3 to both sides. -1 is our b. B is our y-intercept. So we can rewrite the line as y is equal to -3x minus 1 by inserting our plus b where we're used to. Now from there, we could put it into general form just by adding 3x and 1 to both sides, and we get our general form of ax plus by plus c as 3x plus y plus 1 is equal to 0. And that is the general form of the perpendicular bisector of the line segment with the points 4, -3, and -2, -5. So not a lot of steps, not really. You just have to understand the process. So first, find the slope. Second, find the midpoint. Or second, I should say, is find the perpendicular slope. Then write the perpendicular equation. All right, then you're going to find the midpoint. So this is 1, this is 2, this is 3. Number 4 is going to be to find the midpoint. Number 5, here it is, here's your midpoint. Number 5 is going to be to sub the midpoint into the perpendicular. I'm just going to use, instead of trying to spell that, I'm just going to use the symbol into the perpendicular equation, which is here. And then number 6, once you solve that, number 6 is to put it in the general form. And that's this. All right, so 6 steps, and none of them really hard. You know how to do this. We're just putting a little spin on it. You know how to do every single one of these. The only thing new is the midpoint formula, and it's not really new. It's just a new application. All right, so that is all we have for lesson 48B. I'll see you in lesson 49.